Yeah, it's baby E on the train. Yeah, say,
Today
trapping
we'll be
in.
going over the binomial distribution, the geometric distribution, and the Poisson distribution. We will begin with my personal favorite, the geometric distribution. The equation is as follows. P of x equals p times q to the x minus 1, where q equals 1 minus p. P equals success, q equals failure. Now, we will use the geometric distribution when we want to find out the success on a specific trial. And the geometric distribution has to satisfy these three requirements. The trial will repeat until a success occurs, so we'll keep going until we have success. The second one is that each trials are independent of each other. And the third requirement is the probability of success P is constant for each trial. So let's get into our example. The probability that you make a sale on any given telephone call is 0.23. Find the probability that your first sale on any given day will occur on your fourth or fifth sales call. So this is proper notation. Probability of the fourth or fifth call equals probability of 4 plus probability of 5. Then you have the probability of 4 equals this right here is your P, which was given, 0.23. We obtained the Q, which is 0.77 by 1 minus P. And then the X is 4, because we're trying to find the fourth call, X minus 1. 4. So that, and then you just put it in your calculator, that's what you get. And do the same for 5. Except the only difference is this is a 5 change for the X. The P and the Q stayed the same. And then you simplify, you get that. And then you just add up the numbers, and you get this. And basically, why I like the geometric distributions because it can tell you don't have to. It can tell you the probability of when you will get that answer on like which trial, not like the first, not like just have it in a row as we'll see for the other examples. So next up, we'll be going to the binomial distribution. The binomial distribution follows this formula: n combination x times p to the x times q to the n minus x. We can also use the formula in the way n factorial divided by, in parentheses, n minus x, close parentheses, factorial times x factorial times p to the x times q to the n minus x. Now, binomial distribution must follow these requirements in order for us to use it. We need a fixed number of trials, or n. Need two outcomes, success and or failure. Probability of success is the same for each trial. That's independent. And x counts the number of successful trials. Let's go to our example. Each child of a particular pair of parents has a probability of 0.25 of having type O blood. Genetics say that children receive genes from each of their parents independently. If these parents have 5 children, what is the probability that one of the children has O blood type? And the major point about the binomial distribution is that when it happens, when the success happens, does not matter. It can happen for this one. We're looking for 1 out of the 5, so it could be the first child has O type blood, the last child, the third child. It doesn't matter. Order does not matter. So now here we go. Here's the proper notation: P of x equals 1, because we're finding the probability that one of the children has O type blood. So we just replace it. Our n is 5, combination 1, because that's what we're looking for. Alright, that's our x. Here's our success probability, 0.25, to the x, which is 1, because we're looking for 0.75, that's for failure rate, n minus x, 5 minus 1. And then we get 0.3955. And I like to do this before every question of the binomial distributions because it sets it up, it makes it uniform. Here's your n, p, q, and the possible number of successful trials. So after calculating the answer of 0.3955, there's about a 40% chance that exactly one of the couple's 5 children will have type O. Finally, we have the Poisson distribution, which follows p of x equals mu to the x times e to the negative mu, all divided by x factorial. And basically, a Poisson distribution must satisfy these requirements. The experiment consists of counting the number of times an event X occur in a given interval. The interval can be interval of time, which is mostly is time, area, or volume. The probability of the event occurring is the same for each event. And finally, the number of occurrences in one interval is independent of the number of occurrences in other intervals. Think about when you get sick. Like you're more likely to get sick in one season than another. So here's our example. The mean number of accidents per month at a certain intersection is 3. What is the probability that in any given month 4 accidents will occur at this intersection? Like before, I write down my information. We have our x equals 4, and our mu or mean is 3, given from the example. Simply plug it in. Probability 4 equals, you just plug in the numbers, so our mean is 3 to the 4th, because that's our x, e to the negative mu, which is negative 3, all divided by x factorial, which is 4 factorial, and we get this probability. Thank you.
No sound.